Hello everyone, I am Dr. Velamani PS, Professor, Department of Computer Science, University of Science and Technology, Meghalaya. Today we are going to see the overview of TCP IP reference model in the subject computer networks. So the coverage in this chapter: IP address, types of IP address, IP address format, IPv4 versus IPv6, classless interdomain networking, IP address class table A, B, C, D, E, then the overview of the reference model, protocols, OSI protocol stack, and the TCP IP model. So the first, the IP address. The IP address is the short form of Internet Protocol address. It is an unique address assigned to each computing device in an IP network. Internet service provider will assign IP address to all the devices present on its network. Computing devices use IP address to identify and communicate with other devices in the IP network. An IP address is a unique global address for a network interface. It is a 32-bit long identifier which encodes a network's number and a host number. The types of IP addresses: a static IP address and a dynamic IP address. These are all the two types. A static IP address is an IP address that once assigned to a network element, always that will remain same. So they are configured manually. Some of the ISP, that is internet service provider, do not provide these static IP addresses. Static IP addresses are more costly than dynamic IP addresses. Dynamic IP address, it is a temporary assigned IP address to a network element. It can be assigned to different devices if it is not in use. IP address format. The format of the IP address. So it is a 32-bit binary address which is written as four numbers separated by dots. These four numbers are called as octets, where each octet has represent 8 bits. The octets are divided into two components. Number one is network ID and the second one is host ID. So in this diagram, we can see that 32 bits, how it is classified into net ID and host ID. So in detail, if you'll see this in this example, 8-bit octet, that is 8 digits for 1, and another 8 digits, that is for 160, then another 8 digits for 10, then another digits for the 240. So the binary representation equivalent to decimal representation is mentioned here with dot. So network ID represents the IP address of the network and it is used to identify the network. So as we know that host ID represents the IP address of the host and which is identify the host within the element itself. Now the IP address, we know that it is a unique global address for a network interface. This address consists of 32-bit long identifier. It encodes a network number and a host number. So the dotted decimal notations. So the IP address are written in a dotted decimal notation. So each byte is identified by a decimal number with the range 0 to 225. So that is the range in the IP address for the each and every octet. So here this particular example represents 8-bit octets in 4 bytes. First byte that represent 128, then second byte that represent 143 decibel, then third byte that represents 137, fourth byte that represent 144. So which is equivalent to the IP address 128.143.137.144. IPv4 versus IPv6 address. So the internet and technology evolve. There has been an increasing of demand for IP address. So more and more users, network users are getting increased day to day life. In such situation, there is a need to meet the demand for IP addresses. There are two types of IP addresses used today, that is IPv4 and IPv6. Even we can see these IP addresses in our system in the command prompt ipconfig, and it will give the IPv4 address and as well as IPv6 address if it is connected with the internet. So although this IPv4 address in our local home, school or small offices, we should use that. And IPv6 addresses for when you encounter them for the large number of system counting. Example of IPv address 4: 45.79.151.23, which is equal to this 32-bit octet system. IPv6, again we can see this 128-bit in hexadecimal system. So in the hexadecimal system, we can see this 1, 2, 3, 4, 5, 6, 7, 8. So 8 octets will be there, that will be represented not in the form of octet, that is in the form of hexadecimal. We can see this in the number representation as 2601 colon 681 colon 4200 colon C5C0. So there's A, B, C, D, E like this hexadecimal, that representation will be pointed out in this type of IPv6 addressing. So the difference is 32-bit octet system, that is IPv4, the IPv6, that is 128-bit hexadecimal system. So address length. So if we are using 32-bit addresses, it is allowing approximately 4.3 billion unique addresses. On the other hand, IPv6 uses 128-bit addresses, providing approximately 3.4 into 10 to the power of 38 unique addresses. The address notations: IPv4 addresses are represented in a dotted decimal format such as 192.168.0.1. In contrast, IPv6 addresses are represented with the colon, like as shown in the statements like 2001 colon 0 db8 colon 85a3 colon 000 colon 0000 colon 8a2e colon 0370 colon 7334. So the address exhaustion: the IPv4 addresses are running out due to the limited address space. So with this rapid growth of internet connected devices, the exhaustion issue has led to the widespread adoption of IPv6, which offers a significantly larger address for address configuration. So the address configuration assigned statically or dynamically by using dynamic host configuration protocol in IPv4. In IPv6, addresses can also be assigned statically or obtained through stateless address auto configuration. that is SLAAC or DHCP version 6. So address types, IPv4 address have three main types. Number one is unique cast, that is one-to-one communication. The second one is broadcast, that is one-to-all communication within a network. And multicast, one-to-many communication. In case of IPv6, retain unicast and multicast addresses but eliminates broadcast addresses. Instead of IPv6, uses a special all nodes multicast address for similar purposes. Header format. IPv4 headers are 20 to 60 bytes long and have a fixed format. We can see to it. IPv6 headers are 40 bytes long and have a simplified and more efficient format. Additional options are supported through extension headers in IPv6. The classless interdomain routing CIDR. So in this CIDR, an IP address assigning method. This is an IP address assigning method, whereas use of to enhance the efficiency of the address distribution. Also, it is called supernetting. This procedure is an alternative to the older system, which is based on Class A, Class B, and Class C networks. So the CIDR, the range is 255.255.255.240/14. The IP ranges from 0 to 255, which indicates the total number of hosts is 256. The IP address class table for A, B, C, D, E. So in this tabular column, we can see the every IP address in the internet, whether it may be unicast or multicast or reserved, the classful IP range and subnet mask for each block, then the number of blocks, at the same time IP addresses per block. Thus, that will be represented in this particular tabular column very clearly. So the class A, the range is 0 to 255. Then again, this instead of this 127, it starts from here 128 to 191. Then again, we can see this class C 192 to 223. Then multicast B, we can see 224 to 239. Then reserved class E 240 to 225. So that is the representation. We can see to it 0 to 127, then 128 to 191, 192 to 223, 224 to 239, 240 to 250, 255. So in such a manner, 0 to 255, the starting ranges can be defined. The subnet mask, the first three classes, that is 255, the network ID, that is 255.0.0.0, that is the indication here for the ABC classes. Then the multicast and reserved and all, that is for the private and industrial purposes. Probably we are not considering this. And the number of blocks and IP addresses per block for all class A, B, C, that is mentioned very clearly, the total number. Then the overview of reference model protocol. So there are certain terms which we need to keep it in our mind, which can be very useful to study about various type of protocols. Number one is SMTP, that is Simple Mail Transfer Protocol. FTP, File Transfer Protocol. Then POP3, that is Post Office Protocol. TPC, that is Transmission Control Protocol. UDP, User Datagram Protocol. IP, Internet Protocol. ICMP, that is Internet Control Messaging Protocol. ARP, Address Resolution Protocol. RARP, Reserve Address Resolution Protocol. SNMP, Simple Network Management Protocol, Triple P, which is said to be point-to-point protocol, Telnet protocol, that is Teletype Network Protocol, HTTP, which is said to be Hypertext Transfer Protocol. So the HTTP stands for Hypertext Transfer Protocol. This protocol generally, which is used to allow us to access the data from the network which is World Wide Web. It transfers the data in the form of plain text, audio, and video, etc. It is known as a hypertext transfer protocol, as it has the efficiency to use in a hypertext environment where there are rapid jumps from one document to another. Then the SNMP, the simple network management protocol, it is a framework used for the managing the devices on the internet by using TCP/IP protocol. SMTP, that is simple mail transfer protocol, it is used to manage the control for the sending and receiving of the emails. OSI and protocol stack. So in this OSI model, 7 layers are there: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So in case of TCP/IP hierarchy, the first 3 layers are considered as application layer. Then the transport layer, it remains same transport layer. Network layer is considered as internet layer. Data link layer and physical layer is considered as network access layer. This particular TCP/IP hierarchy is the prior model to the OSI model. That is a major point which we need to keep it in our mind. And the protocols involved in the application layer: HTTP, SMTP, POP3, FTP, to handle the user interface and email and file management systems. So the transport layer, in this user datagram protocol and TPC will be used for the transporting, for the communication. And the network layer, that is the internet layer, which is dealing with the internet protocols, ICMP. And the network access layer, Ethernet, ARP, RARP, point-to-point protocols will be used in this lower level layer, which is said to be network access layer. The network access layer includes device driver and network interface card, so which we have studied in our previous videos. Internet layer handles the movement of packets, that is routing. Transport layer, it provides the flow of data between two hosts. Then the topmost layer, application layer, handles the detail of a particular application. A TCP/IP model. So as we discussed already, TCP/IP model was developed prior to the OSI model. It was developed in the year 1970. It is not exactly similar to the OSI model. It is having 4 layers: application layer, transport layer, internet layer, network access layer. These 4 layers will be available in the TCP/IP model. The first 3 layers provides physical standards, network interface, internet networking, and transport function that correspond to the first 3 layers of the OSI model. And these 3 layers are represented in TCP/IP model by a single layer called application layer. The TCP/IP is a higher protocol made up of interactive module, and each of them provide specific functionality. Now the application layer. So application layer, if we are looking to it, it is the topmost layer of the TCP/IP model, and it is going to handle the user interface as well as file handling and also the email services. Different level of services it will provide to the next layer level. So this layer allows the user to interact with the application. When one application layer protocol wants to communicate with another application layer, it forwards its data to the transport layer. So each and every application cannot be placed inside the application layer except those who interact with the communication system. For example, text editor is there means that is an individual application that which can be run without any connection with the web browser or the web server. In case of HTTP, if you are typing certain things in URL, it will connect with the web server and it will get the information. Transport layer, the transmission control protocol will be used in this transport layer. It provides full transport layer services to the application for the communication purposes. It creates a virtual circuit between the sender and receiver and it is active for the duration of the transmission. TCP is a reliable protocol as it detects the error and transmits the damaged frames. Therefore, it ensures all the segments must be received and acknowledged before the transmission is considered to be completed and virtual circuit is discarded. At the sending end, TCP divides the whole message into smaller units known as segments, and each segment contains a sequence number which is required for recording the frames to form an original message. At the receiving end, TCP collects all the segments and reorders them based on the sequence number. Now the internet layer, the main responsibility of the internet layer is to send the packets from any network and they arrive at the destination respective for the road they take. So for this IP protocol, IP addressing host to host communication will be used. So the IP protocol is used in the layer and it is the most significant part of the entire TCP IP suite. Then the IP addressing, which is going to be implement logical host address known as IP address. The IP addresses are used by the internet and highly layered to identify a particular device and to provide internetworking routing. So without IP address, we cannot find a specific system and we cannot send any information or any kind of communication in between sender and receiver. Host to host communication, it determines the path through which the data is to be transmitted. So the path will be determined here. Data encapsulation and formatting. It is an IP protocol accepts the data from the transport layer protocol. An IP protocol ensures that the data is sent and received securely. So it encapsulates the data into a message which is known as IP datagram. So routing, when an IP datagram is sent over the same local network such as LAN, MAN, WAN or whatever it is known as direct delivery. When the source and destination are hide or on the distant network, then the IP datagram is sent indirectly. This can be accomplished by routing the IP datagram through various devices such as routers. Now the network access layer. A network access layer is the combination of physical layer and the data link layer which is defined in the OSI model. A network access layer is the lowest layer of TCP/IP model, which is defined how the data should be sent physically through the network. So the main responsibility is the transmission of the data between two devices on the same network. The functional functions carried out by this layer are encapsulating the IP datagrams into frames transmitted by the network and mapping of IP addresses into physical addresses. Address resolution protocol. This ARP is a network access layer protocol which is used to find the MAC addresses from the IP address. MAC addresses from the IP address. So the two terms are mainly associated with this ARP protocol. Number one is ARP request, number two is ARP reply. So once the sender wants to know the physical address of the device, it broadcasts the ARP request first. Then after that, the network will accept the ARP request and process the request, but only recipient recognize the IP address and send back its physical address in the form of ARP reply. These recipient adds the physical address both to its cache memory and to the datagram headers. Then the reverse address resolution protocol. So it is a protocol that a physical machine in the local area network can use to request its IP address. It does this by sending the device's physical address to a specialized RARP server that is on the LAN and is actively listening the RARP request and it will respond. So with this, we can finish this presentation and video. So in this video, we have covered some of the IP address and different type of IP addresses, class A, class A, class B, class C, and as well as many protocols which is associated with the TCP IP model. Thank you very much. Thank you all. Thank you once again.